Let me put this down here. We're going to be starting chapter 4.4 today. Probably going to try to finish it today. Chapter 4.4 is not as hard as it looks. When you start seeing some of the math, it's going to look hard, but it's really, the math is just a little bit more detailed in it, but it's not horrible, okay? Inverses of functions is basically like what you've heard everywhere else about inverses. When you had division, the inverse of division is multiplication, okay? Just like the inverse of addition is subtraction and vice versa. Well, you can also inverse functions as well. I can take a whole quadratic and invert it, okay, to where it's like a canceling out, okay, of the function, okay? The definition, inverse relation, is what you see here. The inverse of a relation, the relation being some. Okay, they're just saying relation because you can do it with just coordinate points, not just functions, okay? Inverse relation, inverse of r denoted r with the -1, power to the -1. I'm going to get past that point here in just a second. Is a relation defined by switching the first and second coordinates of each ordered pair that is an element. Okay? So notice it gives you the definition. The coordinate point BA such that A, B are real numbers. Well, that's a little bit mathy. Let me show you what that means in the real world. I give you two definitions here. One up here at the top here, we've got R, which is just our normal set. Okay, it's just a set of coordinate points. In your homework, if you wanted to see the inverse, you're literally just going to invert your X and Y. Okay, so your R to the -1 would be, and I'm not going to go through the whole list of these. I do have them wrote out in your notes that I'll download later today. But if we look at this, in R, I have 4 -1. So the inverse would be the set -1. Notice I just inverted them. That's all I did. Okay? I made the X a Y and the Y an X. That's all we did. And that really is the method of inversion we're going to be using. Now, this is the very simplified form. But then notice and look at the other one here. I've got two graphs here. I've got one of them, obviously, my Y is equal to X squared, which is this guy right here. That's a normal function. You've seen it. We know it's a function because it passes the vertical line test. But notice the inverse of it, you literally just switch what? The X's and the Y's. So here, what I actually have here is going to be X is equal to Y squared. And so you get a parabola that's lying on its side. But what do you notice about the inverse? What have we been studying over and over and over again? It's got to pass a certain test. Does it pass it? No. The inverse doesn't. Okay. So sometimes, pardon me, you may have a function that in its, I'm going to say its normal state, I'm just putting this in quotations. In its normal state is a function, but its inverse isn't. Okay. Which in that case, there's some specific math we can do. Okay. You won't have to do it a lot. But the reason I'm saying this is, once again, one, it's good to know. B, I don't know where some of you are headed. Okay. I don't know how high up you're going to go in math. But good news is it's not bad math. We okay so far? You kind of get what it is. I mean, you're kind of like, all right, so far, so good. Okay. Let's get an important note out of the way here and look at this right here. We're faced with another example of the reuse of a notation, okay? You've seen it before because, couldn't I say this? This right here, 1, 4, could be what? What is that? 1, 4. We're talking about reuses of a notation. What could that be right now? Could that not be a coordinate point? Go to 1, go up to 4. What else could it be?
Domain,
Huh?
a domain.
A domain, exactly. Could it be something, a domain from here to here, but never equaling those? Remember when you graphed those? It could be, so it's a reuse of a notation. Well, we're seeing a reuse of a notation. Where do you see the reuse? How about that -1? In normal everyday standards, you would have seen this. A to the -n would have turned into 1 over a to the n. Remember, it's an inverse when you have a negative power, but this is not the case here. This is just a notation issue. It's saying when you see f of -1, g of -1, this is the inverse of a function. Okay? You're seeing the inverse of it. So it's a good caution to know because I used to get confused by these all the time. Those right there would get me. When I'd be studying something in math and the whole time it's talking about interval notation and my brain keeps wanting to make it a coordinate point. Okay? So it's just a reuse. Now let's get to what we're looking at here. How do you know if what you're dealing with function-wise? Let's think of functions. They're going to use the word relation, but let's be honest. We're going to be thinking graphs. How do you know if your function has an inverse? Okay. Let me put this more specifically. Every function can be turned into an inverse, okay? But it doesn't mean that they're a function when they get turned. Let's put it that way, okay? Sort of like the parabola, right? The parabola, whenever you turned it into an inverse, it was no longer a function anymore. Well, we know that by knowing of a function is what we call one-to-one, okay? One-to-one, or mathematically, sometimes you'll see it, you'll hear it be called injective. In this class, I will use the term one-to-one, but if you go on to like another class, another math class after this one, if they say the word injective, they just mean one-to-one. And after I show you what it is, you're gonna go, oh, okay. Okay? A function is one-to-one if for every pair of distinct elements, x and x2 in the domain of f, we have where x1, a point in that function, cannot equal x2. This means that every element of the range of f is paired with exactly one element of the domain. Everybody get that? I'm good. I can just walk on. Everybody understand what that meant? Show what this means. Let me give you an example. Let me give you an example of what something is not one-to-one. And I'm going to help you out here because, you know, what's nice is I'm going to give you another test. Okay? Another test we can do here is called the horizontal line test. If you look up the definition of function, remember we did the vertical line test for what reason? What happens if our vertical line, why do we draw it? Just for the fun of it?
Function.
Well, how do you know?
It only passes once.
Once of what?
Through the-
Which line? Oh, just the line, right?
Yeah.
That's exactly what you're looking for again. To see if something is a function, you draw the vertical line, right? And if it hits that line of that function more than once, that means you have two x values that are going to be the exact same, right? Which means you don't have a function. And we all agree the reason you know that this part right up here is not a function because it didn't pass the vertical line test. Because it hit here and it hit here. Not a function. The horizontal line test will say this. If I draw a horizontal line through my function, that's already a function, you already done your vertical line, you know it's a function. If I draw a vertical line and I get two y values happening twice, well, guess what? You do not have a one-to-one function. Therefore, this function does not have an inverse because whenever I turn it on its side, what's going to happen? Where it went across horizontally, it's going to go across vertically as well. And so without having to do any math, you can go, it didn't pass it. Okay? So let me show you one that does not pass. Look here. Obviously, we have the function. We know it's a function. There it is. You've learned this one. This is the absolute value function. It does pass the vertical line test, right? But notice they drew a horizontal line. Horizontal line is stating, hey, if I made this guy, okay, if I changed him, if I said, hey, I want to change him from this and do the inverse, well, first off, we know that all we got to do is switch the x and y. That f of x is basically a y there, right? This would turn into x is equal to the absolute value of y. Well, here, I'll draw this in red. Can we all agree that the absolute value of the inverse will look something like this? Blow this down just a little bit here. It's just going to be turned on its side, right? But what does it not pass now? It didn't pass the vertical line test. But also, before I even found the inverse, what did it also not pass? That horizontal line test. So it failed the horizontal line test. And so therefore, if it fails the horizontal line test, you will not, hear my words, you will not have a function when you invert it. When it becomes the inverse, you will not have a function. How do you know this easily in your homework? Well, first off, know your base graphs again, right? Like if you see a formula and it says to you, find the inverse, and then there's a little box next to it that says, well, what if there is no inverse? Well, you can do a whole bunch of math and get a red bar, or you can go, man, I know what an absolute value looks like. An absolute value looks like this. You do yourself a little sketch, draw a horizontal line and go, nope, I got two y values that are the same. That means there's no inverse. You're done. You walk on, right? If you draw it and you have a one-to-one function, which I will show you what it is, and literally a one-to-one function is saying, hey, while x is, can we all agree I'm never going to have the same x value twice on this function, not the inverse. I'm kind of demystifying the definition. It says where f of x cannot equal f of x2. It's saying you're never going to have two x values that are the same. Well, that's true. But here's the problem. Guess what? This is not one-to-one because it also says what? I have to have different y values as well. But that's not the case. I have 3 happening twice. So my input, when you have a one-to-one function, when you give it an input, you'll always get a different output. You will never get the same number, ever. Different numbers produce different things. When I show you one short, you're gonna be like, oh, that makes sense. When I show you a picture of a one-to-one function, okay? Are you good with the horizontal line test? If I just showed you a bunch of graphs, could you go, this one has an inverse, this one doesn't, just by drawing a horizontal line? Okay. Let's look at a one-to-one function now. We'll look at that one. First off, it obviously passes the vertical line test. But notice, once again, because it's a function, currently it's a function, we're always going to have different x values. That's the definition of a function. But notice, every single x value is going to produce a distinct y value. I will never get the same y value twice. If I put in 2 way up here somewhere, I'm going to equal something, right? It's going to be a massively larger number. But if I put in -2, I'm going to get a massively small number. Or actually, yeah, it'll be right here, almost at 0. You see what I'm saying? They're not the same. Good? So all this had to do was we had to do what? Draw my horizontal lines. Notice, I can know this one right here. If it asks me on the homework, hey, is this a one-to-one function? It won't ask you if it's a one-to-one. It'll say, does this have an inverse? I can go, let me think about this. Well, I know for a fact that g of x is actually equal to x cubed. Isn't that the base function I'm looking at? I also know that x cubed looks roughly like that. Notice I'm not doing some highfalutin art here. I'm just giving myself a sketch from stuff I learned in 3.3 and 3.4. Hey, that's a one-to-one function. Yes, this has an inverse. I got to finish the math now. But if it gave me an absolute value or a parabola, okay? Or think about it, even if it gave me something like this, like what if it gave me 1 over x squared? Remember that one? That's one that looks like this. Like that. That wouldn't pass the vertical line test, would it? Because you could get the same y value. It's a mirrored. Okay, does that kind of help you out a little bit? You know the graphs, you cut down. Half the battle is knowing what the graph looks like. You're going to find that out in this class. If you can kind of have an idea of what the graph looks like, man, you've helped yourself out. Okay? So yes, this relation, which is g of x, x plus 2 cubed, does pass the horizontal line test. So this function is a one-to-one function. One input gives you one distinct output. Okay, you're never going to get the same number. Whereas with a parabola, that was what's so great about a parabola. I can plug in a 1, and man, when I plug in 1, I'm going to get this output of y, but that means I'm also going to be able to double it on the other side. Okay? Finding the inverse. Well, you didn't think it was just going to be that easy, right? It's not bad. Let me read you this, and then I do it. It's funny they give you this, and they kind of change it a little bit. If you look up tutoring, I do like how they change it. But let me read to you. When I give you the example, you're going to be like, oh, okay. And I'm also going to show you how to check it if you choose to check. Okay? The checking process isn't hard, okay? But I just do want to let you know. It can look messy. It will stretch your algebraic skills a little bit sometimes, but that's not a bad thing, okay? But notice it says here, let f be a one-to-one function. Kind of needs to be, right? Okay? And assume that f is defined by a formula. To find a formula for f to the -1, perform the following steps. Replace f of x, or whatever function they're calling it, in the definition of f with the variable y. You're changing it back to a y. Instead of using f of x, we're going to go back to, like, instead of y equals mx plus b, we'll use, they were using f of x, right? We're going to go back to y. Okay? The result is an equation in x and y that is solved for y at this point. Solve the equation for x. Here's what I do at step 2. And I'm going to write this out, but I just want to tell you one so you can hear it if you decide to watch the lecture later. You have y equals mx plus b. We're going to use that as our base function right now. Switch them. Now make it x is equal to ym plus b. You're literally just switching the x and the y. That's all you're doing, switching. But then solve for y again. You switch them, but solve for y. Let me show you what I mean, okay? Watch what I'm going to do on this function. I have x minus 1 cubed plus 2. First off, you should know, is that a function? Is that a one-to-one function? Yeah, it's a cube. Yeah, I know what a cube looks like. That's going to be one-to-one. It would pass the vertical line test. Okay, so I can go to step 2 on this. Let me scroll down here. Anybody need this up here? It's in your notes, just in case you need the notes. Watch carefully. Okay? And don't forget, I have these in your notes, the whole steps. But watch what I'm going to do. I'm going to solve. So I'm going to rewrite real quick. I've got this f of x is equal to x minus 1 cubed plus 2. Well, first we'll change f of x to y. So let's change this to y is equal to x minus 1 cubed plus 2. Now here's where it gets ambiguous, because if you kind of read this definition literally, it's going to say to you, and if you actually look it up in your book, in your textbook, they don't do what I do. What I'm going to do right now, irony. If you go to the tutor section in Hawks, they do this. And it's the way I was taught. Okay. So I'm showing you kind of a nicer way in my mind. At this moment right now, before I do anything, I'm switching my x and y. Isn't that the definition of a function? Isn't that what I did at the very beginning? I just took the x's and y's and flipped them. When I very first showed you we had a coordinate point x and y, the inverse would be what? Flip it. Your y becomes x, x becomes y. So flip it around. Make this x is equal to y minus 1 cubed plus 2. And now solve for y. Get y by itself again. Okay? So at this point right now, you're literally at a moment like you had on your midterm. Remember that one question that said, hey, make this equation I just gave you, turn it into a function of x, which is just solving for y. That's all you're doing here is solving for y at this point. So I'm going to come in here and go, okay, well, how about I subtract 2 from both sides? That gives me x minus 2 is equal to y minus 1 cubed. Well, to get rid of that cube, can we all agree I just need to take the cube root of both sides? Okay, well, let's do that. Let's take the cube root of both sides. Notice that's going to give me the cube root of x minus 2 is equal to y minus 1. Then how about I just take this and add 1 to both sides? I'm going to come up here and notice here I get y is equal to now the cube root of x minus 2 plus 1. Final step. Now, good news. Hey, Hawk does this next part for you. Bad news, I don't on your final. Okay? You've got to turn this back into a function because that's what we deal with now in math, right? We deal with functions. But you're not dealing with y, we're dealing with f of negative 1. X is equal to the cube root of x minus 2 plus 1. And that would be the inverse of that formula. Nice part is go look it up on Desmos. Okay? If you put these in on Desmos, you could actually see where you've taken this function, this cube root function, or sorry, this, yeah, not cube root, sorry, this power of theta, this cubic function, that we know what it does this, right? It's literally taken it and turned it. And it's giving you an inverse. Every inverse has a way to remove itself, right? If I have a positive 1, how do I get rid of it? How do I make it go away?
And subtract one.
Subtract 1. If I have negative 1, I can add 1, right? You can also do the same with functions. Now I'm showing you this. They're never going to make you do it in your homework. I'm going to show you right now, though, because can you just intuitively know, like, and be honest with yourself, can you look at this formula right here and go, yep, that looks good to me? No, you really can't. I mean, let's be honest with yourself. Maybe you get really good at it. Y'all are gonna, like I said, I've said this before, y'all are smarter than me. Eventually you're gonna be able to tell, yeah, that kind of, once you picture the graphs of these, you can kind of go, yeah, that looks like the inverse, okay? But there's a way to check yourself. Watch what's gonna happen. Let's go back in time. Like I said, you don't have to do this. I'm gonna show you the math on how to do this. It is in your textbook, but it is a good skill to have. What would happen? Do you remember whenever you learned this? What do you call that? You learned it in 4.3 or 4.2, maybe 2. One of the two. Remember whenever we were composition of functions, when we put them together, you take one function and you take this other function, you put it inside the other function. Remember that kind of a little bit? Well, watch what I can do here. can I take f, and we're just gonna use f right now, f, and compose it with f of -1? They are two separate functions, aren't they? One's an inverse function, one is the normal function, okay? So if I do that, knowing that my -1 function here is what? It's this guy right here, right? You with me so far? So I can take f of the cube root of x minus 2 plus 1. Which that's basically saying what? I'm going to take that whole junk and replace it where? Inside my original function, right? Well, watch what's going to happen. When I do that, I'm going to get the cube root of x minus 2, okay, plus 1 minus 1, all raised to the power 3, plus 2. Because that's what f of x is saying right there, because I put everything into that guy right there, right? Well, watch this. Don't these guys just go away? Okay, well then I'm going to be left with the cube root of x minus 2 cubed plus 2. But what happens to this cube here and that index of 3? Isn't that the inverse? Right? A power of 3 will get rid of a cube root because they cancel each other out. Okay, so then I'm going to be left with x minus 2 plus 2. Those guys cancel out. I'm just left with x. I know I did the right math. Because a function, its inverse does what? It negates the function. And that's exactly what I did. I'm left with nothing at that point. There is no function left. Speaking mathematically, that's the wrong way to say it, but that's how I'm going to explain it to you mathematically right now. Does that kind of help y'all out? So if you get a little worried, did you do the right math? You can always plug your inverse back into the normal function, and you will always come back to an original x, okay, if you did the right math, okay? The hard part is sometimes that's some algebra in there you got to remember, right? Okay. Once again, a good skill to keep. We good? Okay. Inverse function aren't as common as you. If you're worried about inverse function right now, don't freak out on them, but they're there now. Okay. We will. You get into trig, you deal with inverse functions a lot. You get into calculus, they're everywhere. Okay. Or they're not everywhere. You need to learn to use them because they're a useful tool. Believe it or not, the stuff you're learning now makes the bigger math that everybody's scared of. It's actually kind of easier, ironically. Makes it even easier. You're learning the hard stuff now. This is like automotive class. Think about automotive class is really hard when you first start it because you're having to learn all the tools. What does this tool do? What does this tool do? But once you get good at the tools, putting together an engine's easy. Because you're using the tools. You're letting the tools do the work. That's what algebra is. It's the tools to build the engine. Okay. Inverse of a restricted domain. This you will not do very often, but I do want to show it to you. Okay, just very, very quickly. Notice here. First off, what's my base function? I don't have it drawn here, but what is the base function of this guy right here?
Explain. Square root of x.
Square root? No, what base function? If you had to draw a graph of this guy, what would it be? Yeah, x squared. It's just a parabola, right? Because of that guy right here, right? That says, hey, the base, if I just had to go back down to the very base function of this, what is this graph roughly going to look like? Well, it's an x squared. Let's think about it. It's a parabola.
Oh, nothing like a parabola.
It does, that power of 2 doesn't say a parabola?
Yeah.
No, these
Down
down,
there don't.
down here don't, but what's our base function? I'll show you why it doesn't look like a parabola here in a little bit. These don't. So I was asking what this guy is. This guy's a parabola moved where? 1 unit to the right or left?
Left.
Left, why left?
This one's
That's positive. And then we're gonna go up or down?
down.
Down. So isn't this vertex form? Isn't it giving you a vertex already? Of where?
-1, -3.
Exactly. My vertex is -1, -3, which is telling me roughly, let's say we have a parabola that looks like that. Can we all agree? More or less. This guy right here is not 1-to-1, is it? So we just can't do math anymore? So whenever I'm modeling cancer rates later on in life, I find out that they're on a parabolic deal, and I'd really like to find a way to solve them, but oh, too bad. Can't do that because they're not 1-to-1, and so therefore there's no way for me to do that. I can't inverse them. I can't invert it because I need to do that. No, we can restrict the domain and only solve, and that's what we're doing here. I know my inverse is here. But look at this. That's where my parabola is at, right? But wouldn't this guy right here, isn't that my line of symmetry? Remember that from back in the day? Well, if I restrict the domain, that's what's happening here. I'm restricting the domain at the vertex. I'm saying, hey, instead of dealing with this whole parabola, this f of x here, how about I just restrict it from 1 or -1 to infinity? And let's just deal with that side. And when I do, there is the graph of my inverse. It's only going to do that. Therefore, I have a function. Does that make a little bit more sense? You're not going to have to do this, okay, a lot. You might have to do it once or twice, not on a final. But it's good to know. Okay, it's good to know that you can say, hey, things need to be bounded sometimes, and we only need to work in certain areas of things. And I'm not going to get into the math of this one. The math of this one, I do on your notes. Reason I really, if you go look at your textbook, their textbook looks really weird, okay? Because they like to jump steps, okay? I show you the steps that are in between, the little interval steps. But think about it, a parabola, at some point when you're finding an inverse, your intuition is to say, man, they're probably going to be in a square root somewhere because I got a power of 2 in there. Eventually, I'm going to have to get rid of it. And the only way to get rid of a power of 2 is take the square root eventually. But when you take the square root of an even power, you're always going to have to add a what to it? Plus or minus. Remember that? That's what they're doing in your notes. You get 2 answers. So you basically have 2 inverses. One that's positive, one that's a negative. Okay. Also, the reason I show this, another good way to check your answers at home, Desmos. If you go into Desmos, put in the main function, then put in the inverse, you will see a mirror image across the origin of your graph. It will literally flip itself, where you can like take a piece of paper and fold it over, and it'd be like they're canceling each other out. Okay. Good. How do you feel about inverses so far? Okay. Let's do some homework examples. Find 4 points contained in the inverse. Express the values as integers or simplified fractions. Okay. I'm going to show you 2 ways to do this. Okay, and this one has a step 2. First off, just looking at the function. What type of function is this? It's not a function right now. It's literally just a what? Y is equal to, that's not a function. So this makes it easier. I'll show you why. Because it was a function, right? And then they did what? They changed it to y. And then what are we supposed to do after that? Remember, flip the x and the y. There's your inverse. For this one, there's your inverse. Because this one already started off with y, you can just flip your x and the y and you're done. But you still didn't answer my question. If you had to graph this, what are you going to get? Very good. You're going to get a line. Okay. Well, like I said, let's do this two ways. One, if I came up with the inverse, the nice thing about this one is this. I can come right over here. And since it's not a function, I can just flip the x and the y. And change this into x is equal to negative 2y minus 2. Now find 4 points. That's all you gotta do. Find 4 points of your new graph. So you're gonna come over here. Using that, you can come over here and immediately just go, hey, x and y. But now instead of plugging in x, well, I mean, you could if you want to, you could find it, put in the next value, then solve. But I'm going to come right in here and go, well, since I've inverted this, let's go ahead and do 1, 2, 3, and 4. Well, don't I just come in here and do this? Negative 2 times 1 minus 2. What's that going to give you? A negative 4. Negative and positive. I don't think I should have to go through every little math because you're probably going to use your calculator on that anyway. I would. Okay. When you keep doing this, notice you're going to get negative 6, negative 8, and negative 10. Oh, look how easy that was. And then you come right in here and go, okay, well, then this is going to be negative 4, 1, negative 6, 2, negative 8, 3, and then negative 10, 4. But there is another way to do this one, since they're not dealing with a function. You could just go ahead and solve right now, couldn't you? In its base form, right here. Could I have not done the same thing? Now, let me see if you catch on to this. Notice if I just want to come in here with that function as it is and go x and y, well, on this one, I would probably just be plugging in x values, right? Well, how about I go 1, 2, 3, and 4 again? I'm going to pick very simple numbers. Because even if I get ugly numbers with my calculator, you're probably going to use your calculator to get some really nice decimal, and I mean, or fraction that's already simplified. There you go. Pop it in there. Well, for one, am I not just going to get 2 times 1 minus 2? Once again, I'm going to get what? Negative 4. Negative 6. Negative 8. Negative 10. But the problem with those, that's the original function, right? That's the points from that guy. But what do they say? When you're finding the inverse, what do we do with those points?
Excellent.
Flip them, right? You mean what they look like right there? So you don't have to change the whole formula now. You don't want to. Just figure out your points and then take them and do what? Invert them. Make the x's y's and the y's x's. So it's really up to you how you decide to do it. I'd like to give you a few ways to do things like this. Makes it a little nicer. But now the question remains is, hey, what's the domain and range? What type of function is it?
Linear.
Wouldn't that be all real numbers and all real numbers? Draw a picture. There you go. What's my domain and range of that line? This is where knowing your base function really does help out. Okay. If it wasn't this, what are you going to do? Look at your inverse and look for the implied domain. Right? Same thing. These functions work the exact thing. don't see that -1 up there and go, okay, well, how do these work? They're still functions. They still behave in the same manner. If there's a square root in your inverse, guess what? It's got a domain and it's got a range. Okay? And you can take it because you know now how to take these functions and move them up or down, left and right. Okay, so think about that. Or also check yourself on Desmos. Go pop those bad boys in Desmos and go, oh, I can see the domain and range from here. It's going to show me a picture of the graph now. I can kind of see it. So it can help you out a little bit. Okay. Don't get hung up too hard. The math is actually pretty simple-ish. Okay. Just don't get freaked out by ugly numbers. Okay. Let's do another one. Look at this guy here. First off, find a formula for the inverse of the following function if possible. First off, you have to decide, does this even have an inverse function? Well, what's the base function? So what I'm telling you, without having to do any math, you should be able to go, okay, S of X is equal to, if you had to get that function down to its bare bones, this is what this looks like when I first started learning about other functions. What does it look like? Exactly. 1 over X, right? Before I did any sort of translations to it, before I said, well, let me increase its magnitude or let me skinny it up, whatever, its base looks like that. What does the graph look like though? Yeah, you've got the weird little loops. It's going to look like this. Well, looking at that base little just crappy graph that I just drew, can we say that that's a one-to-one function though? Yeah. It's always going to pass the vertical line, or sorry, the horizontal line test. Now, you may be sitting here and going, what about where it starts to even out right there? Just because it looks like it's evening out, remember, it's getting closer and closer and closer to zero there. It's just never going to touch. So it still would pass. Okay. So yes, this guy does have an inverse. So before you even start doing the math on some of this, draw out your graph. 1, it's good review. Okay. 2, then you're like, okay, this is a one-to-one function. Now I can do the math. Or you don't waste your time doing the math and all of a sudden you get a red bar and find out you could have just clicked that. And then you're mad at me for some reason. Okay. So let's do the math. First off, write down your original function. S is X is 2 all over 3 over X plus 2. We're going to change that S of X into what? Y. Exactly. Change this into Y is equal to 2 all over 3X plus 2. But now what am I going to do? Switch the X's and the Y's. Are you good so far? Okay. So let's change this into X is equal to 2 all over 3Y plus 2. And at this point, this is when the math really starts. Now you're solving for Y. Okay. And this can be kind of a puzzle sometimes. This is going to stretch your algebraic. Remember how I said, if you took me in Dev 2, I said to you, when we started learning how to manipulate stuff, I said, hey, better get good at this because this is a process. Sometimes to get things along, we got to move backwards and forwards for a little bit. This is going to be one of those. Notice, I'm going to write it up here so I have more room. I have X is equal to 2 over 3Y plus 2. I'm going to cross multiply all of this on the bottom up. I'm taking the whole denominator and doing what? Moving it up. I'm basically multiplying by its inverse, right? I'm multiplying by 3Y plus 2 over 1 on both sides. And then I'm going to rewrite. I've got X, 3Y plus 2 is equal to 2. Well, now, let's get rid of the X. Let's divide off both sides by X. And I have 3y plus 2 is equal to 2 over x. Subtract 2 from both sides. That cancels out. We're getting there, aren't we? 3y is equal to, well, 2 over x minus 2. Now I gotta do what? Divide off the what? Exactly. Divide by 3, divide by 3, divide by 3. Well, be very careful. Up again. Notice, I'm going to remove this little section right here real quick and do the math so you can see what's happening there. You have 2 over x divided by 3, but how about we make this as a 3 over 1? Which in essence, what you are seeing is 2 over x divided by 3 over 1, but you should all know that you don't divide fractions, you do what? Multiply by
So
of the second term. It's very good. So you're actually going to multiply by 2 over x times 1 over 3. And you get 2 over 3x. There you go. So now we can go back down and rewrite this as y is equal to 2 over 3x minus 2. Last step, which you don't have to do because look, they give it to you up there. So this would be your answer. And I'm very confident that's my answer because I'm not going to do it right here, but in your notes, I do check it by taking that function there and placing it back inside the original function, and I get back to my original x. And so then I know, hey, the math worked. 100%, not even worried about it. Well, and for you, you're lucky, you get a green bar that lets you know. Okay? Well, how about you do that one then? Give you about 2 minutes. And then I'm just going to give you the answer and then we will check the answer. I'll go back through the math very quickly, but still. Try that out. Ask yourself this first though, because I see everybody jumping in real quick and doing the math. Did you draw your graph yet to see if it even has an inverse? The base function would have been what? The base, without any fluff.
fifth root of x
The fifth root of x, which looks like what?
sideways s.
Yeah, it looks like this, doesn't it? So is that a one-to-one function? Yes. It passes the horizontal line test. If it passes the horizontal line test, you have a one-to-one function. So can you move on? Does this thing have an inverse? Yes, you can move on to the math. That can help you all a little bit. Okay. Go ahead on. I just didn't want you to start thinking I tried to fool you. that. Do you have trouble anywhere? Did some of it algebraically get a little weird for you? Maybe around the fifth root part?
At the last part, I wanted to keep going, but I didn't know.
It's tough. It's tough to find, yeah. Could you check? This is one of those weird ones to check. Remember, I'm gonna be doing R of R1 of X. I'm gonna show you the checking process. You don't have to do it, but I'm gonna show you the checking process. Look at it carefully. I've got this original function, so I'm gonna have R of 5/3 to the fifth. Which means I'm gonna have this equals 3 to the fifth root of x plus 5/3 to the fifth power minus 5. This one, double check. Okay. Notice on this one, hey, the roots disappear. Right? The index, the power gets rid of the index. So then I'm gonna be left with 3 x plus 5/3 minus 5. But realize this is 3/1, so therefore it does reduce out. Leaving me with x plus 5 minus 5, which of course, gone, equals x. Your math worked out. Do you need to do that? No, I'm not gonna make you do that. Important skill, maybe? Maybe sort of like what I used to say back when I first taught some people here how to do quadratics. Hey, you know how you check a quadratic? Boil it back. Right? You can always distribute it back and get back to the original function. To always double check yourself. There's always ways to double check yourself in math. And believe it or not, that's one of the reasons I fell in love with math. I mean, my bachelor's is in history. I love history. Now my master's and stuff is in math, but history was always like, yeah, you had concrete dates, but then like if a professor asked me like, why did Napoleon do X, Y, and Z? Right, 500 words. That's a lot. And then he's really asking like 500 words. Well, he did it because he had little man syndrome. Look, I got it done in 5 words. But math was always like, here's the answer, and I can check it. I didn't have to worry about what the professor thought that day. Okay, so I don't know. Some people don't like that concreteness. This last one here, looking at it, all it says here, it says determine if the following function has an inverse. Does it?
No.
It doesn't?
Yeah.
What is its base function? X cubed, right? What does my graph look like in X cubed? Kind of like a sideways backwards S, doesn't it? Is that a one-to-one function? Yeah. So, yes. It has an inverse. That's how your homework is going to go throughout this whole time. And that finishes up with chapter 4. As a quick review, remember in chapter 4, what did we learn? We learned 1, it's very important that you go back to 3, 4. If you don't understand your functions, your shapes of functions, you're going to have a bad time. Okay? 2, we learned how to move them. Up, down, left, right, skinny them, widen them, crush them, stretch them. We learned what it meant to compose them, put them together. Hey, you can take one function and compose it with another one. We also learned that we can add functions. We also learned when you can divide functions. We also learned, which is why if you go back in time to intermediate algebra, why did you learn to have polynomial rational expressions where I had one polynomial over a polynomial? Why did I need to learn how to do that? Oh, because now look what you learned how to do. You learned how to take one function and divide it by another function. Why did you learn how to add functions? What does it mean by dropping the parentheses? That's why we learned how to do that. Okay? 4.4 and 5.1 will be due still Friday. 5.1 will start tomorrow. We probably won't finish 5.1 tomorrow. We'll probably finish it on Thursday. So if I were you, get home and get 4.3, 4.4 done. Okay, because you're gonna want to spend that extra time on 5 point. Okay. It's not bad, but chapter 5 is gonna be the area. This is usually, I hate to say it, this is when I start losing people. Okay, because chapter 5 it gets a little bit weird. Okay, and then chapter 6 comes around, and you're just gonna hate it. Okay, because then you learn about brand new functions y'all never had to deal with, unless you did what I said to do in intermediate. How many of y'all do the extra credit chapter 17 and actually do it, not cheat and let your phone do it for you? Okay. Chapter 17 in intermediate is chapter 6 in college algebra. Okay. It's exponential functions, natural logs. It's that where you see like log of x. Okay. They're not hard, it's just the math looks weird. I'm just kind of building you in now for this because, guys, we're at week number 5. And we're almost done with week 5. We've only got like 2.5 weeks left of class. So the final will be here before you know it. Tomorrow, I will try to remember, I will bring you all a note card, a little colored note card. Okay, a little 3x5 note card. As I said, you can do whatever you want on it. Anything. Okay, you just gotta make sure you turn it in with your final. Okay. Another little thing about your midterms. If you didn't do well on your midterm, a lot of your problems, I will say this, word problems. Okay. Missing the word problems is what was the killer. Okay. Because that was a lot of points. That was the back page, had 4 word problems. That was 25 points just gone off the top. Okay. And that's literally how I looked at it. I looked at the back page and said, oh, you didn't do nothing. Then I started your grade at a 75. Okay. And that's what me I remember I took away 1. Okay. So it would have been 30 points. Okay. So if word problems are your thing, study those a little bit more. But now's not the time to fall behind. You need to, I would suggest getting ahead. If you have a chance, get ahead. So you have time to study. Okay. I will be offering now, I'm going to say it now because I want you to plan ahead. July 17th is our last day of class. That's your final date. I will also be giving the final on the 16th as well. Okay. So it's the last 2 days, 16th and 17th, I'll be doing the final. Okay. You'll have homework due on the 16th, by the way. Okay. But if you want to take your final on the 16th, you can, just to get it done early. Okay. I'm not giving you any extra credit. You can just do it if you want to early. Okay. Good. All right. I'll see you guys tomorrow. We'll start 5-1.